A storm of historic proportions has slammed into the Philippines, leaving devastation so widespread and so scientifically baffling that experts are openly admitting they've never seen anything like it. At least 8 people are confirmed dead, entire provinces have been drowned under rapid flooding, and more than 1.4 million residents were forced to evacuate ahead of landfall. But beyond the tragic human toll, it's what scientists discovered inside Fung-wong's structure that has them genuinely frightened. This wasn't just another super typhoon. It was a storm that behaved in ways meteorologists once considered impossible. A storm that broke rules, defied expectations, and raised the unsettling question of whether the Philippines is now facing a new breed of mega-cyclone. Fung-wong, known locally as Uwan, made landfall in Aurora province with sustained winds of 185 kilometers per hour and gusts roaring up to 230 kilometers per hour. The winds ripped roofs from homes, took out the trees like matchsticks, and plunged entire cities into darkness within minutes. Streets became rivers, houses were ripped from their foundations, and landslides wiped out mountain roads that had stood for generations. All of this happened just days after Typhoon Fong left more than 200 people dead and only weeks after a magnitude 6.9 earthquake struck Cebu. Even for a nation accustomed to an endless barrage of storms, this sequence of disasters is something far more alarming. Humanitarian agencies have warned that this is not routine, stressing that the Philippines is experiencing escalating climate and seismic pressures that demand immediate global attention. But what shocked meteorologists most is the unbelievable size of Fung-wong's circulation. Satellite images showed the storm's cloud shield stretching roughly 1,800 kilometers, large enough to cover nearly 2/3 of the entire Philippine archipelago. Its rain bands reached from the Pacific coastline all the way to the Western Plains, a scale of atmospheric organization that experts say should not be physically possible for a single storm system. Even more unsettling, the eye wall remained intact long after the typhoon slammed into Luzon's mountains. Normally, rugged terrain tears storms apart, but Fung-wong barely flinched. It held its structure, kept its symmetry, and continued delivering destructive winds far inland, suggesting it was drawing energy from an unusually powerful reservoir of heat and moisture. Before the storm arrived, authorities knew they were facing something dangerous. The rarely triggered Signal Number 5, the highest warning level in the country, was raised, a classification reserved for catastrophic events capable of causing near-total destruction. Mass evacuations unfolded across coastal towns, with more than 1 million people abandoning their homes. In Cabanatuan, one of the hardest-hit cities, residents rushed through chest-deep waters to salvage furniture, pets, and documents as water levels surged through neighborhoods in minutes. By dawn, thousands of houses were partially or totally destroyed, leaving many families with nothing but the clothes on their backs. The scientific concerns actually started when meteorologists reviewed the storm's behavior using data from satellites, radars, buoys, and ground stations. Typically, this multi-layered network allows experts to predict a storm's evolution with reasonable accuracy. But Fung-wong exposed major vulnerabilities in this system. Several Doppler radars in Luzon went dark as the storm approached, exactly when forecasters needed them most. Coastal tide gauges failed just as water levels began rising. Power outages knocked out communication with key weather stations. Suddenly, the people responsible for tracking the storm were forced to rely on partial, inconsistent readings, a worst-case scenario that made forecasting even more difficult. Inside emergency operation centers, local leaders wasted no time. In one Aurora municipality, officials activated sirens and loudspeakers as soon as the alert level was raised. Police and barangay officers swept through communities, urging residents to evacuate. Some families refused to leave, worried about losing their belongings or livestock. But the order was absolute. If they didn't move voluntarily, they would be removed for their own safety. No rescues once the winds begin, the mayor warned, a reminder that even emergency teams have limits in a storm like this. The evacuation centers filled quickly, packed with families clutching bags, blankets, and their most precious possessions. Despite these precautions, tragedy still struck. 2 residents in that same town lost their lives. One drowned in a fast-moving surge. Another killed when part of a roof collapsed during the storm's peak gusts. Both deaths occurred when they attempted to return home too early, unaware that a second surge of wind and water would arrive even after the storm's eye had passed. Officials expressed heartbreak, knowing they had done everything possible, but still couldn't prevent every loss. It was another painful reminder that in a storm of this scale, even perfect preparation has limits. Perhaps the most dramatic moment of Fung-wong's rampage unfolded offshore shortly after midnight. A fishing vessel, the San Lorenzo, issued a desperate distress call after losing engine power and 8-meter waves. The fishermen were adrift, taking on water, barely clinging to the rails as the raging sea swallowed their boat piece by piece. A Philippine Coast Guard cutter, the Bagong Bayani, was dispatched into the storm, a mission many described as nearly suicidal. The crew had to strap themselves to the deck to avoid being washed overboard as hurricane-force gusts battered the vessel. Visibility was non-existent. The navigation systems flickered with error messages. For more than an hour, the cutter circled blindly through the dark, guided only by sporadic radio bursts and lightning flashes. Then, in a moment rescuers later described as a miracle, a lightning bolt illuminated the broken silhouette of the San Lorenzo. The Coast Guard managed to fire a line across and pull the fishermen to safety one by one. Minutes after the final survivor was hauled aboard, the fishing boat vanished beneath a massive wave. The fact that the crew survived it all left even veteran rescuers shaken. It was yet another sign that this storm operated outside the boundaries of normal expectation. As the sun rose, scientists began analyzing the data. What they found was unprecedented. Some satellite readings suggested a storm diameter close to 1,800 kilometers, pushing against the upper bounds of known typhoon physics. The Joint Typhoon Warning Center believed Fung-wong's wind field was far wider than typical storms of its category, raising the possibility that it behaved like a multi-vortex system, essentially several storms rotating within a larger envelope. Pagasa, following protocol, took the conservative route and kept official measurements within known extremes. Even so, the disagreement between agencies highlighted how poorly understood storms of this scale truly are. Conflicting analyses left emergency planners unsure which areas needed the highest level of warning, forcing them to make decisions under uncertainty as the storm barreled toward land. On the coast, the aftermath revealed even more concerning discoveries. Engineers measured storm surges of 3.5 to 4 meters in some Aurora bays, far higher than official models predicted. Entire towns were flooded long after the wind subsided because torrent after torrent of mountain runoff collided with rising seas at precisely the wrong moment, high tide. Floodwaters pushed hundreds of meters inland, submerging communities that were not marked as high-risk zones. In several provinces, families who believed they were safe found themselves suddenly trapped by walls of water. Scientists later admitted that outdated maps, incomplete river data, and underestimated surge models kept them from predicting how far the flooding would reach. Relief operations faced their own crisis. The government had pre-positioned more than 2 million food packs, perhaps the largest stockpile ever prepared for a single event. And still, demand surged beyond expectations. Roads were buried under landslides, bridges had collapsed, and ports were shut down. Supplies became stranded in warehouses just hours away from areas running out of food. Climate experts voiced frustration, saying the storm revealed how fragile the disaster response chain still is, even after years of investment. So, what exactly made Fung-wong so extraordinary? Scientists identified several converging factors: record-high sea temperatures east of Luzon, unusually deep ocean heat content, a favorable Madden-Julian oscillation phase, extreme atmospheric moisture, and abnormally low wind shear. Each factor alone is significant. Together, they create storms that behave like nothing in the historical record. As one atmospheric scientist put it, the storms we remember are gone. What's forming now are storms we haven't imagined yet. Fung-wong's message is clear. Nature's rules are changing, and the storms of tomorrow may not resemble the storms of the past. The question now is whether we can adapt fast enough, because the next stage of this new climate playbook is already being written.